Hello, everyone. I'm Dr. Richa Gupta, working as Assistant Professor at Department of Computer Science Engineering, Jamia, Hamdard, India. The topic for my session is Machine Learning Implementation in Recommender Systems. So let's start with our session. So machine learning implementation in recommender system. This is the outline for my talk for this particular session. Let's start with the machine learning. Machine learning is a branch of artificial intelligence, which is concerned with the design and development of algorithms. So it works by using algorithms, and these algorithms constantly searching for patterns, looking for data that can be understood and grouped together. It uses this data and algorithms to help it learn from the past and make them guesses and prediction about the future. So it imitates a human-like intelligence. So this diagram, as you can see, shows how the ordinary system has evolved into the machine learning, and now it can learn, predict, and improves the our data set or our data or the model. Though we have a lot of knowledge about machine learning, I would only take a few topics which are related with this particular talk. So let's see what are the different learning algorithms. But before this, we also have to see why we need machine learning. We need machine learning, though we have different kinds of algorithms already existing. Why we need machine learning? That's because it enables the computers to interpret the data more quickly and currently and automates the task which can handle multivariate data and multidimensional data by advancing the system capabilities. Now, coming to these algorithms, machine learning can be categorized into supervised and unsupervised learning. As the name suggests, supervised learning means the presence of a teacher. So you learn in the presence of a teacher. So basically, supervised learning is when we teach or train the machine using data that is well labeled, and unsupervised when there is an absence of a teacher. So there is neither a classified nor a labeled information, and it allows the algorithm to act on the information without any guidance. So supervised can be classified further into classification and regression, and underneath are the various algorithms which can help them, which help to implement classification method and further into the regression method. Similarly, these k-means hierarchical, Gaussian, hidden Markov model, neural networks are helped to implement the clustering methods. Besides this, we also have the association under the unsupervised learning. So classification means that it is about the predicting a class or discrete values like true, false, male, female, yes, no. So you're classifying into some specific classes, while in the regression, it is about predicting a quantity or a continuous value like age, salary. Clustering is an unsupervised task which involves the grouping the similar data points. So it is basically for grouping the points which are together. So like if you have a apple, banana, mango, so you cluster them as fruit. Now, next we have association. Association again is an unsupervised learning task or learning technique which is used to find the important relationships between the various data points. In the clustering, we have grouped or gathered them. In the association, we find what are the relationship between them. This is a learning system model, very important because the success of machine learning system depends on the algorithms. So this learning system is very important to implement perfectly. The algorithms control the search, find and build the knowledge data structures. The learning algorithms should extract useful information from the training sample. So this is what we do whenever we have a raw data. We process that particular data as per the need. We normalize it, we clean it, and then this clean or pre-processed data is further divided into training data set or the testing data set. And this, with the help of this training data set, we build a model, and we validate this model on the various parameters like accuracy, then F1 score, sensitivity, specificity, and check the accuracy of the model. If it needs to be hyper-tuned for some parameters, then we do that. In case there is some other issues or some other features we need to carry on the data, we go back into the feature engineering state, where we do further cleaning into the data set. And again, we divide into training and testing data. If our model is correct, we have achieved the accuracy after checking with the validations, various validation parameter, then we check our model with the testing data, which is again the part of the process data itself. So this is how we are learning. We are making a model to learn on the data set, this particular data set, which is training and testing is coming from the raw data, which has been distributed after pre-processing into the testing and the training data. And the model we create on the basis of the training data set, and further we test our model on the testing data set. So we are making a system to learn as per our data which we are entering. So these are the few applications of the machine learning, as you can see, and these are the real world examples where we are using them. At most of the places nowadays, recommendation systems are being used. So, machine learning applications are used, like the recommendation system, fake news detection, traffic prediction, speech recognition, healthcare, real estate prices, customer churn, customer prediction chatbots. So let's start with the very first recommendation system, which is of course, our topic for today's session also is that, and see how ML helps in this recommendation system. So what are the recommender systems or recommendation systems? These are, or why we need the recommendation system. These are the systems for recommending items to user based on examples of their preferences. These items can be anything like books, movies, web pages, news groups, blogs, anything. Now, many websites nowadays are using recommendation system like YouTube, Netflix, Amazon, Pandora to increase their sales. Why we need the recommendation system? Because nowadays, it is no more the era of information, no more the era where we need the information, but instead it's the age of recommendation. Instead of one size fits all, we have now customized things. So recommendation lead to some very good product choices also. So what happened is, if you are, let's say, if you're even the Google, the famous search engine now, if you use, let's say, Isaac Newton in your Google search engine, then it comes up with the idea that people also search Albert Einstein. So it is giving you the recommendation that if you are searching for Einstein, it has discovered that you're looking for some particular inventors or discoverers. Then the earlier people who were looking for the discoverers have also looked for Stephen's, the Hawkins, then Copernicus, Einstein. So it has suggested or recommended you those scientists or the inventors too. Similarly, on the YouTube, if you're looking on some TED Talk or some documentaries, so next time the YouTube itself will start on your homepage, will give you lots of recommendation related either to the TED Talks or the talk you have heard on the TED Talks. It could be any documentary, it could be some information related. So your YouTube would be flooded with those recommendations to watch on. This is how the recommendation system works. There is a user, and there's a user. Whenever a user visit any web store, online store, for any product, it gives a rating. It stays there for some time. So there's a behavior. It might look or search for something. There are queries. There might be some restriction attributes also. So these are being entered into the recommended systems, which studies the rating, behavior, queries of and the attributes of the user. This goes into the database. This database have the data related with the other users who have visited this particular online store or website. So based on these attributes and the previous user attributes, they are being compared. So let's say for any product, the user has given some rating. This database will look on what the other user have given the rating for the same product. If the ratings matches, they can recommend that you might also interested in product B and product C too. So then on looking into those, comparing those attributes with the ones already available in the database, so wherein you have already trained or you have learned and made the database to learn on previous users' data, now you're testing it. So this new user is like a testing data, and then you recommend the objects to this particular user. How this recommender system works? This recommender system works in three main steps, that is data capture, data analysis, training, and testing. And it looks for these important parameters of the variables like behavioral, demographic, psychographic, geographic. So what happened, let's say there is a person A which visit an offline store regularly. Then that store knows what their regular customer taste is and would always give the required object or the merchandise to them. But if the same customer is visiting some new store, then it takes some time to gather information, understand what type of customer is this, and accordingly, the recommender system would provide or the recommend merchandise matching to this preferences, his or her preferences. So they can even categorize this user or the customer into certain customer archetypes or the buyer. So recommendation system plays a very similar role as what the sales agent play in the offline stores. Whenever you visit a store, some salesperson come to you and ask what you need, ma'am, or what you need, sir. In that case, they're actually asking for what are your preferences. So when you tell your attributes or the parameters, you need this, you're looking for this, any book, or maybe any comic book or any comedy book, they will take you to that particular section and would rather keep on giving you some comic books. Ma'am, you would love the book. This book is very good. And they are recommending you this book on the basis of what the previous users might have bought in the same genre. The same way the recommendation system is working here also. So here what the human salesperson depends on the intuition, while the recommendation engines instead rely on machine learning to process huge customer data set and consider a broader range of parameters to perform this classification and targeting process. This includes behavior, browsing behavior, purchase history, content usage, personal information. Besides, not only this, the recommendation not only just work on the customer or not just on the humans, but it also works on the contextual data. That means if any holiday season is approaching, so it can recommend a product accordingly also. That let's say if it is a Christmas, if it's Easter or Thanksgiving, it may recommend a product as per that particular holiday. So that is also done by the recommender systems. So if we see the example we see as per the user A, there are three steps: data capture, data analysis, training, and testing. So whenever a user is visiting, you are capturing the data for how long the user is browsing any category, or how long he or she is, the user is looking on that particular web page. If the user is looking for some particular item or some related items, then this is the parameters they are catching. Now they will analyze it. These analysis means they are actually looking up into the database with respect to this particular user. And then they are training and testing. That means they have already created a model as per the previous user needs. And then these parameters which they have taken and are comparing it with their database. So as per those analysis, they will come with the recommendations. That is the training and the testing phase. So first coming up a user is a data capture, asking what you need and understanding what are the requirements of gathering those information and taking to that particular stack where the required products are is the data analysis. And from that stack, recommending the products in the same genre to the user, to the customer, is the training, the testing, data science. So this is how the recommender system works also. Now, recommender systems work on the two main methods, that is collaborative filtering and the content-based filtering. In collaborative filtering, what happens is uh, if a user A has visited, is visiting an online store, let's say a movie store, then that particular user is looking for some, let's say, thriller movie, let's say for a movie A, then in collaborative filtering, the website or that particular store, online store, will take on that if a person has take on the parameters, okay, it is looking for movie A in the database. Sorry. So it would suggest to the customer, to the user, that the people who have bought movie A or have rented, let's say, product A, have also rented or also bought product B, product C. So this is like where the comparison is with respect to users. So the users who have bought A have also bought B. So this is how the collaborative filtering work. And here the user is being compared with the other users in the database. While in the content-based filtering, what happens is recommendation are based on the information on the content. That means not on the other user's opinion. It is basically content of items rather than the user's opinion. So it would rather be like um, if if a user is wanting product A, so the web store, online store might come up with that for product A if you're buying. So it would say you might also like product B, product C. This is again based on the same thing was written in the different. Here it is not written the users who have bought A have also bought B and C. Instead, it has written in other way that you may also like product B and C, right? So this is how the content based. They are not talking with respect to user, but respect to the items, related items which the user is looking for. So that is content based. Looking here is the example with respect to movies, the user who is looking for Avengers. In a collaborative filtering, what is happening is it is saying that similar users who have bought Avengers have also rented or bought Thor and some other movie. So you may also like these movies too if you are taking the Avengers into account. But in the content base, it is saying that if you're liking Avengers, maybe this person is highly into the thriller genre or maybe into the Avengers series. So they say that if you're content based, it may say if you like Avengers, you may also like Thor, Green Lantern, Wonder Woman, likewise, Flash, likewise. So that is about the content base. Now, further, this recommendation system not only is divided on the basis of content base or the collaborative filtering, but collaborative filtering can also be divided. Into memory based and the model based approaches. Hybrid approach is the one where both memory based and model based are taken into account. So now, memory based is further divided into user based filtering and item based filtering. Model based approach is the approach where the new representation of items are built based on the generative model. So there is a small dense vectors and you reconstruct every time a user item interaction values from its own representation of users and the item. So they are not taking any of the user into account, but every time the user is checking with a type of item for how long the user is interacting with that item or with that web page. So looking into that, they create a model-based approach. It is basically deals with the statistical approaches, matrix like matrix, factorization, further divided into ALS, NMS, that is non-negative matrix factorization, ELS altering least square. While in the memory base, we have user memory based approach. It items are represented directly by their past. So if the user has bought something earlier from the same website, earlier, then they would look into the past history of that user, that what orders they have placed earlier, and would recommend accordingly that maybe the user is interested in same kind of product. So here in the large space vector is there, we can use nearest neighborhood method also. In this, low bias is there in high variance system. So now, what is memory based is further divided into user based and item based. What is the difference between that? User based filtering. Let's say, imagine that we want to recommend a movie to our friend, Stan, let's say. So we could assume that similar people will have similar taste. We generally say similar people have the similar taste. So suppose that me and Stan, sorry, have seen the same movies earlier, and we rated them all almost identically. Suppose Stan hasn't seen the movie, let's say Godfather, and if I love that movie, it sounds logical to think that he might love that movie. Reason being, we have seen earlier same kind of movies. We have rated almost all the movies almost on the same content, right? So it sounds logical to think that he will like the movie Godfather too, as if he has not seen that. So with that, uh, we have created an artificial rating based on our similarity. So here, the user-based collaborative filtering uses that logic and recommends item based on the similar users to the active users. While in the item-based filtering, back to the stand if I take into account, instead of focusing on me or his friends, we could focus on what items from all the options are more similar to what we know he enjoys. So this new focus is now termed as item-based collaborative filtering, because now we are looking into, okay, he enjoys classical, maybe he enjoys other kind of movie, but if he is looking for some other kind of product, so we are not looking at what he is enjoying, but if he's searching for some new kind of product, we would rather recommend or open up the options which are almost similar to what he enjoys, so that the more genres, more option can be provided to the stand. That is item-based filtering. Now, moving further, I would I would like to say that how the so far how the machine learning helps in the recommendation system. We have seen this here, how the recommendation system works, but how the machine learning is helping out in this recommender system. Machine learning based recommendation system are the powerful engines, and it helps to segment customers based on their user data and behavior patterns and target them in a personalized product and the content selection. So ML algorithms actually enhance their capabilities over time through the experience. The more data they process, the more relationship among data points they will spot, and better they will fine tune their models. So such models typically are used for like predictive analytics, for making decisions, for recommending systems. So they represent a window into which the customer think, as they allow us to frame logic behind those specific patterns of the customers, and they shed light on the current sales or even predict the future developments also. So here in the machine learning, wherein we are using training and testing, we are actually making our recommendation system to learn something. So whenever there is a learning, whenever we are predicting or predicting that this user might also like something else other than what he or she is looking for. So we are predicting something. Herein, we are using the machine learning algorithm. So basically in the training and the testing phase, we are using the learning phases. We are using the machine learning algorithms, wherein the machine learning comes into the function. Okay, So this is all about how the recommendation system works, how we can use the machine learning approaches. Now, what are the top recommendation systems on the internet right now? Those are Facebook, Amazon, LinkedIn, Netflix, YouTube's. So Amazon recommends products, search, results. Facebook recommendation engine helps in finding out the friend suggestions. Netflix recommendation system to provide the movies. Then LinkedIn helps him to provide to suggest the job ad, connection, courses. YouTube recommendation system helps to prioritize the videos you look for. You should look for the channels, subscriptions, any relevant news, if any. So what are the ML-based recommendation system benefits are? Of course, a better user experience. Then focus on the right product. You can, if you're not uh, knowing what actually you want to look for, and you're looking some product from other category, in that case also the recommendations helps you to come to the correct category by looking on to your patterns, studying on to your patterns, what you are looking for. So let's say if you are looking for some exercise machine, or let's say any physiotherapy product, you actually don't know that product name or something, and you are searching something again and again related to it, then this pattern would be learned by the machine learning algorithms. And then from the database, it will end up with the exact product you are looking for. So sales drive, of course, with the help of recommendation systems, the sales take a boon for the online stores, and the revenue grows, and also helping data-driven decision making also. Okay, so if some, let's say, product is not getting saved too much, so those recommendation system helps you how you can increase your sales of those products, how you can make them visualize to the people by you can give away them in offers as a gift so that people have visibility of that product, more visibility of that product, which is right now hidden, or people are not visiting, users are not visiting that particular product. So this how the machine learning helps. The impact of recommender system on the economy, it has increased the purchases of Amazon by 35%. This is all by McKinsey. During the Chinese Global Festival in 2016, the Alibaba sales has increased by 20%. The YouTube, most 70% of the time people are watching what the YouTube help you in recommending. 70% of what people are watching on Netflix comes from the recommendation. This is a small global economic chart, which not only helps in telling us that how the economy has taken a boon, but also is predicting the future that it will, with the help of this recommendation system on various online store, how it will move ahead till 2025. It's going like 7,391 billion US dollars. It is going to make this recommendation system business on various e-commerce sites. The major players, these are the major players which would contribute into the recommendation engine, and Asia Pacific is the fastest growing place, and it is predicting by 2026 how much revenues can be created by these major players. So to come to the end of this, I conclude my talk by saying that machine learning nowadays are being used in all sectors of human life, and three most important domains are movies, documents, products, reviews. Though the recommendation system development lacks studies in the early stages and the late stages like maintenance, though the evolution of recommendation system from its inception reveals an efficient and effective recommendation system, which is of course in need of an hour. Recommendation system is an adoption of machine learning approaches, and which help to learn from the user information and make help in making the robust and accurate recommendation system. Though the software engineers still don't have any clear idea that what kind of model they should focus on to have a very robust recommendation system. In this era of Industry 4.0, where of course we are moving to 5.0 also, where machine learning is mostly dominating, and recommendation system will guide the machine to take the appropriate steps in all particular situation. The performance of recommendation system also depends on the quality of data. So work need to be done to overcome the problems of data sparsity and the cold start. The robustness of, I believe the robustness of the recommendation system is a function of both quality of data and the algorithm which is being implemented. So better the algorithm is, better is the result. The result can be used to train the machine and can lead to the development of knowledge base, which in turn will help to make appropriate decision during any real-time problems. So last but not least, the data privacy. Since it is data privacy is very important issue to be addressed in recommendation system, because to develop a recommendation system, we consider users' data, users' choices. So does that need to be guarded well to develop a trusted recommendation system, and we can develop and we can have a full faith on a trust on any store online we are visiting. So on this note, I conclude my talk. Thank you for being such a patient listener and providing me this opportunity on such a big platform. Thank you so much. Thank you.